When 8 times 10 to the 14th hertz light shines on a plate of unknown material, it is determined that the stopping potential is 2 volts. Determine the work function in electron volts and the cutoff frequency. Okay, so first here, we need to remember about the stopping potential. So we know that Ke max is equal to E times V naught, where V naught is the stopping potential. So if my stopping potential is 2 volts, okay, so that's going to be Ke max equals E times 2 volts, and that's going to equal 2 electron volts. So my max kinetic energy is 2 electron volts. Now I can go to the photoelectric effect formula here, which Ke max equals H times F minus the work function. I know the max kinetic energy, that's 2 electron volts. Okay. H is, what is that? 4.14125 times 10 to the negative 15th. This is the electron volts. I'll write this out just to be clear. Electron volts seconds value for H that we need. And my frequency is 8 times 10, excuse me there, 8 times 10 to the 14th, that's hertz. Okay. And I don't know the work function. Okay. So go ahead and multiply this stuff out. So 4.14125 E negative 15 times 8E 14, and that works out to be 3.313, and this will be electron volts. So this is 2 electron volts, this is 3.313 electron volts minus W naught, and so easy to find that W naught is just 1.313 electron volts. So there we go. Got the work function. Now it asks for the cutoff frequency. Remember, for the cutoff frequency, let me do this in a different color. For the cutoff frequency, that's when the max is 0. At the cutoff frequency, the max kinetic energy is 0. So I'm taking this formula, but this is 0 now. So this is 0 equals H F naught minus W naught. Okay. And what I'm trying to find out here is, of course, the cutoff frequency. So that's going to be the cutoff frequency equals the work function divided by H. Okay. So I'll just put in my work function, 1.313, that's electron volts. And I'll put in my value for H, 4.14125 times 10 to the negative 15th electron volt seconds. Okay. And go through and I get 3.1705 times 10 to the 14th hertz. Okay. And one thing to watch out for, I know that the cutoff frequency has to be less than the frequency that was originally given, because electrons will only be emitted if the frequency of light is greater than the cutoff frequency. And I know that at this frequency, electrons were emitted. Anyway, I can see that this is less than this. So that doesn't mean this is right, but at least it isn't obviously wrong. And indeed, this is the correct answer.